Welcome back to the Scotti-BYTE channel, and this is Scott. So yesterday I had an issue with Docker, and specifically I noticed that my Nginx proxy manager Incus container had consumed 28 gigabytes of disk storage, and I was wondering how could that possibly be. Well, the bottom line is it turned out that Docker was using a lot of excess space that I did not expect. So today I'm going to make a video about fixing common Docker issues and perhaps fixing even less than common Docker issues. So Docker applications are easy to install and to upgrade, and I've always liked them for that reason. And I recommend nesting each Docker application inside of a dedicated LXD or Incus container. And in the particular case that I had yesterday, that really paid off because as opposed to affecting multiple applications in my environment, I just had one application that I had to deal with. So Docker applications over time accumulate orphaned stopped containers, orphaned networks, orphaned volumes, images, and even build caches if you do Docker build commands. And a lot of times these things simply don't go away on their own. So although Docker system prune, which is a really great command that's existed since something like Docker 1.3, theoretically removes these dangling data structures, there is a folder in /var/lib/docker/vfs/dir, and that contains all of the layers used by running containers. However, if you have a container that terminates abnormally, these files are left behind, and over time they can grow significantly. So this video is going to be about that and some other Docker issues. Here we are inside of the Incus container that I used to install the PHP Dynamic QR Codes application that I presented, I guess, a couple of months ago. And one of the things we know we can do is a Docker space compose ls, and it lists that that application is up and running, and it also tells me where that is running. And of course I can do a Docker PS, and it lists out the application and calls it out. In this case it's calling out the container for the app and calling out the database for the app, which are actually two separate instances. And if I do an ls of this app, you can see that it has a number of components, notably the docker-compose .yaml. So if I cd to the top level of this and do an ls, you can see that we only have this one folder, and that's where that application is installed. And on the channel, when I show the installation of a Docker application inside of an Incus or LXD container, I always show creating a folder for it first. So today we're going to create one of the things we're going to do anyway is we're going to create a separate folder, and we're going to create one called docu. So we're going to do a make dir on docu, which is Docker usage. And I'm going to cd into docu, and I'm going to do a nano on docker-compose.yml. So to begin with, the Docker application is called docu. Here's the image it's coming from. We name the container docu. We say restart equals always, and it's set to port 9090, which we'll go ahead and remember. It's a less frequently used port number. Keep in mind, since I have an application running inside of this container, we're going to want to pick a port that's free, and I know the port that I'm using for the application in this container, the QR code application, is using port 80. So you may want to change this port number to the left of the colon if you're running several Docker applications on your container, VM, or whatever you're running them on. So now I'm going to do a Control O, and enter and a control X to exit the nano editor. So now I'll do a docker compose up-d. That goes ahead and pulls and starts this Doku application. Now that the application is started, I want to find out what the address of this container or virtual machine is. In my case, an Incus container. So I do an IP space A, and my Ethernet device is at 192.168.80.144. So I'll go ahead and make a copy of that, and I'll go up to my Google Chrome browser. I paste that address in, and I do a :9090 for port 9090 where Docker usage is running. I hit enter, and it goes ahead and brings up this dashboard. Go ahead and go full screen on this. The Docker usage application has several tabs at the top of the screen. The default one is the dashboard screen. That goes ahead and indicates how much room the images are taking up, how much room containers are taking up, how much room volumes, logs, and build cache are taking up. You can go over to the images screen, and you can see also which particular images are on this machine. And obviously we have the PHP dynamic QR code application for both the database and the main app, which we saw by doing the docker ps command. And then of course Doku's out here running now, so you're seeing it as well. You might be glad to know that this application also has an option at the top that allows you to go into dark mode. So now we're in dark mode, and it reminds you here also that you can use the docker image prune command to prune any containers or container space that is unused for images. We can go over to containers, and it tells you can also do the docker container prune, and here it doesn't use very much space in regards to that. But in volumes, that's where our data is primarily stored. It's using 207 megabytes for the database and only 3.6 kilobytes for the main application. And then we have bind mounts if we had any bind mounts, which we don't. And finally, we have log files, and it's giving the size of the log files as being 253 megabytes, 41 kilobytes, and 557 bytes. And then finally, the build cache, you can always do a Docker builder prune to be able to prune those things as well. So back at the terminal here, Doku is really a very nice application. We also have the ability to do a Docker system prune -A, which prunes everything related to the current Docker system. So I hit enter, and it says this will remove all stopped containers. Notice that's very important, because if you had a container stopped, it would remove it. It will also remove all networks that are not used by at least one container, and all images without at least one container associated with them. And if you use the docker build command to build any of your Docker applications, it will also clear out the build cache. So I'll go ahead and say yes and hit enter, and it said the total reclaimed space was 0 bytes. However, I really believe that I have a lot more space that can be deleted. After seeing the result of this command, you might even wonder if this command works at all. So we can do a docker compose down, and that will go ahead and shut down the Doku application. And if we issue the docker system prune-A again and say yes, you will notice that it goes out and deletes the Doku application usage in Docker. Docker has a lot of commands that really aid in maintenance, and one of them that I like is this docker RMI, which really means remove Docker images, If they happen to be dangling images, that means images not associated with a container. However, that previous command we used really should have done the same thing. The reason it came back and said Docker RMI requires at least one argument is because this particular little mini script did not find any containers that were orphaned, or any images, that were orphaned. So in reality, Docker really does use disk space that those utilities do not account for. And so one of the things that we can do is we can issue a program called ncdu, which is short for, believe it or not, Incus's disk utility. So if I do an sudo ncdu on /, then it would do an ncdu from the root level down on the disk. And it asks for my sudo password, and I enter it, and it says that ncdu is not found. So we can install ncdu with the command sudo apt install ncdu, and it installs that utility. Now that it's installed, we can go ahead and issue that sudo ncdu /, and it will go ahead and scan your entire system from the root level down and give you a summary of what is using most of your storage. Now that ncdu has completed, you can see that 9 gigabytes of storage are taken out of /var. If we hit enter, you can tell it's also coming from /lib. If we hit enter again, you can see that it's actually in /docker. And if we go down again, it's in /vws, and finally it is in /dir. And what these things are is these are all the pieces of orphaned container layers that have been left around and they have not been maintained, and that is what is using the 9 gigabytes of storage. Now the thing is, we can't just arbitrarily delete everything in this /var /lib /docker /vfs /dir folder, because some of these things are being actively used. So I ran across a routine. If I do a Control-Z, that goes ahead and exits ncdu. I have a Docker container that I found out on the internet, and this thing is an application that accesses the Docker sock, and it is called Cleanup Volumes. If I hit enter on this thing, it goes ahead and downloads that Docker container, and then it begins deleting all of those elements that are no longer needed or orphaned from the systems. And it does say can't removed on those items which are currently being used. So now that that's completed, if I go ahead and do an up arrow to the ncdu command and run it once again, we'll see what kind of an effect that had. And you can see that it went back to 7.5 gigabytes. So it did remove 1.5 gigs that were being unused, and they were in that location that we previously looked at. If we go down to var, lib, docker, vfs, dir, here are the things that are left over, but presumably these are the ones that are in use. So in summary, Docker is a great application virtualization system, and having a single Docker server running multiple applications can be susceptible to infrastructure outages. And LXD or Incus provide a good means to isolate the impact of Docker issues affecting other applications. And so the tools presented in this video are helpful in correcting common Docker issues. So anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit your notification bell, and we'll see you next time.